Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help you understand how to find x-intercepts. Now, we're going to be looking at just parabolic examples, but the method for finding x-intercepts is the same for all functions. So, I've got a nice picture of a graph here, and if you've got some sort of graph, and maybe it looks something like this, I don't know, just to make up an example here. The x-intercepts are, just like their name implies, the locations on the graph where it intercepts the x-axis. In this picture that I drew, there's 3 of them. Key fundamental idea is that at all 3 points, the y-coordinate is 0, and that's the fact that we'll use to find our x-intercepts for all functions, not just parabolic functions. So let's get started. So we're going to take a look at these 4 examples here. Y equals x squared minus 9. So the idea is we're going to set y equal to 0. And now solve for x. This one can be solved pretty easily by just adding 9 to both sides. So we got x squared equals 9, so x equals plus or minus 3. Now, intercepts are ordered pairs. They're points on the graph. So the intercepts here, one of them is the point 3, 0, and another one is the point negative 3, 0. If I put them on the graph, 1, 2, 3, 0, 1, 2, 3, 0. There they are for this one. And I think what I'll do here is I'll just do them kind of case by case here. All right, let's take a look at this one. All right, so again, we put 0 in for y, solve for x. This one kind of looks like it's factorable. It's looking like x minus 1 and x minus 2 to me. I always double check when I factor. Yep, outer and inner term is the minus 3x. Yes, we're good. All right, so now we have the product of 2 things equals 0. So either x minus 1 equals 0, in which case x would equal 1, or x minus 2 equals 0, in which case x is equal to 2. So we have 2 intercepts here. One of them is the point 1, 0. The other one is the point 2, 0. If I graphed those, right, 1, 0 would be here, 2, 0 is here, and that's where they'd be. All right, let's take a look at this one. So this one, let's solve this a different way. Let's apply the quadratic formula, and also I'm going to try to make myself a little more room here. Computer system's good for this one. We can shrink this down maybe a little, lift this up a little. All right, and maybe we'll move this one off to the side here for later. All right, so let's take a look at this one. And again, this one let's do by the quadratic formula. So we're going to have 0 equals minus x squared minus x plus 2. So x is going to be, the opposite of b would be 1 plus or minus the square root of b squared. Now negative 1 squared would be 1, minus 4 times a times c, all over twice a. So cleaning this up a little bit, 1 plus or minus square root of, all right, looking inside of here, minus and minus is plus, and this product is 8, plus 1 is 9 over negative 2. So we're going to have 1 plus or minus 3 over negative 2. Now let's take them one at a time. 1 plus 3 is 4 over negative 2. That's minus 2. So that's the point minus 2, 0. I'm not going to bother color coding that one. Actually, I'll do that in a minute. And then the other one is going to be 1 minus 3 over negative 2, which is negative 1. So that corresponds to the point negative 1, 0. If I put these on the graph, right, negative 2, 0, 1, 2, 0, negative 1. Ooh. And good thing I kind of looked at that again. I forgot about the 1/2 in the bottom. This one. Let's see. 1 minus 3 is negative 2. Divided by negative 2, that's positive 1, not negative 1. So that was the point 1, 0, not negative 1, 0. My bad, but I'm just going to leave that in the video. That's okay. 1 minus 3 is negative 2 over negative 2. That's plus 1. All right, so that other intercept is plus 1, 0. There it is. All right. I guess I'll just leave that red dot there. All right, last example, and I'm just going to make myself a bunch of room for it. Let's get rid of this stuff. Oops, I forgot what that example was. Let's see, I believe it was y equals 2x squared minus x minus 3. And again, to find the intercepts, we're going to put 0 in for y. Solve for x. This thing's probably factorable, but I'm going to go ahead and just use the quadratic formula. Opposite of b, plus or minus square root of b squared would be 1 minus 4 times 2 times negative 3 all over twice a. All right, clean it up a little bit. All right, so looking inside here for starters, this is going to be positive. 8 times 3 is 24, and 1 is 25, and then over 4. So that's going to be 1 plus or minus 5 over 4. Let's take them one at a time. 1 plus 5 over 4. That's 3 halves. So that's the point 3 halves 0, because your intercept is a point. The other y coordinate is 0. And then we've got 1 minus 5 over 4, which is negative 4 over 4, which is negative 1. So that's the point negative 1, 0. If I put those on the graph, I see I already got a red dot still there. I'll do these in green. 3 halves 0 is 1.5. That would be there, give or take. Negative 1, 0 here. Get rid of that dot that I don't want there anymore. So there's the intercepts for this function. So again, this video is about how to find intercepts of any function. The x-intercept, you're setting y equal to 0, solving for x. And for quadratic functions, that will typically yield 2 intercepts. Conceivably, you can have 1, like if the vertex just touches the axis, or you might not get any intercepts in some examples. You might have something that kind of looks like this, where it doesn't cross this axis at all, and I've got other videos about how you know that. As far as how you know, look up the video on discriminants. So anyway, I hope this video helps. Have a great day.